So we just had our equation for the fundamental theorem of algebra. And how do we use that for these problems? Let's look at number 3. We need to determine the zeros. Remember what that means on your graph. You have a coordinate that your y value is 0. That's why they call them the zeros. You're supposed to just solve for the x. So I have x cubed plus 4x. I'm thinking how to solve for that. You could use rational roots. Probably don't want to. So I'm going to just factor out a GCF of x. X times x squared plus 4. Oh no! Can I factor any more? Huh? This is not a difference of squares. If you try to do your x, you would have this situation, right? There's a 0x there. Right? So a times c is 4, b is 0. There are no two numbers that multiply before and add to be 0. What does that mean? Now you can apply the zero product rule. Ah, look at this. Class, can x equal 0? Yeah. Yep, that's one of our solutions. We're going to write some words in there, so I left a little space. How do you solve for x over here, class? Subtract 4.
And square root it.
Then you said square root it.
X equals 2.
I'm okay. So now I have x equals plus or minus. Remember, the square root of negative 4 is square root of negative 1 times 4. No. Thanks. Class, what's the square root of negative 1? And class, what's the square root of 4? 2.
X plus or minus 2i.
So these are two solutions, right? It's x equals positive 2i and x equals negative 2i. Okay. Class, is this real or imaginary? Real. So we have one real. Let's see how this works. And how many imaginaries? 2 imaginaries. So if I go back up, it says the degree, determine the zeros. We did that. What's the degree of the problem? The answer is 3. Well, how does the fundamental theorem of algebra work? I have one real, so 1 plus 2 equals the 3. Special winner? Newer. What number do you want to do? 2. What do we do?
X squared minus 6x plus 9 will be x. So x minus 3 and x minus 3.
And then when you solve it, you get what? Okay, I was just reminding a student that you actually write it twice. And this is why they might write like something like this. X equals 3 with a multiplicity of 2. So, Noor, what is the degree?
Second.
Yep.
And the real one is x equals 3 and x equals 3. And there are no x.
Does that say most of 2?
Multiplicity of 2. Good job, Noor. Isaac, where are you? Number 1 or 4? What do you do? Yeah, it's already a binomial, guys, right? See that? Now what do you get, Isaac? What's the degree of the polynomial? Huh? Degree's like exponent. What's the highest exponent? 1. How many reals do you have? And how many imaginaries?
You didn't stand for it.
0. Raise your hand if you got that so far. Alright. Special winner for number 4. Cameron. You could. Where's the 0? If I asked you where's the 0, what would you say? Okay, we are finding a 0, but I'm kind of implying there's a 0 somewhere over here.
Oh, where x cubed would be, and x squared, and x.
Okay, I only need one of those.
Oh,
Do you know which one?
x squared.
Okay, why do you only want just x squared?
It's half x.
It's half of 4. And if they're halves, then you can do this. You can factor by Xbox method. Cameron, what is A times C?
-1.
B value?
0.
2 numbers?
-1 +1.
So, essentially what we just did there is you would have x squared minus 1 and plus 1. You would just factor this one to be a difference of squares, so x plus 1, x minus 1. This one is not factorable.
But you get I at the end.
Yes. So when you set that equal to 0, x equals -1. Cameron here, x equals
Or 1.
1. This one, same thing, set equal to 0. Subtract 1, square root.
You get I.
Not just I,
Plus or minus I.
plus or minus I. So this would give us our 2 reals and our 2 imaginaries. So 4 is the highest degree, equals 2 plus 2. So for examples applying the fundamental theorem of algebra, what did you guys notice about the imaginaries?
They always have an I.
On this column, what do you guys notice about the numbers? Do you see any odd numbers? Oh, they always come in pairs.
I
Oh.
love math. You don't love math? What's wrong with you? I love math.